Alright, now that we are acquainted with the terminologies about the sets, the terms, we are now going ahead to apply it, but majorly for the two-set problem. So we have example number one. Given the sets, have the universal as elements 1, 2, 3, 4, 5, 6, 7, 8, 9. Set A has elements 2, 3, 4, 5, 8. And set B has elements 1, 3, 5, 7, 8, 9. Where that symbol there shows the universal set. Now they need us to find A intersection B, A union B, A intersection B complement, A complement intersection B, A complement intersection B complement. So that is the problem given to us. We need to solve it. So before we do anything, we have to first of all establish the common elements in the set A and B. 3 is a common element, 5 is a common element, 8 here is a common element between A and B. So we are going to represent this can be best handled if we have the Venn diagram. So I'm going to have set A here, set B here. We have identified that the common elements between A and B are 3, have 5, have 8. Those are the shared elements between the two sets. Then the rest of the elements in A are going to come here. They are not in the B. They are complements of B. So I have 2, I have 4 on those. 2 and 4 are complements of. We are now going to look out for complements of A. I have 1, I have 9, 7, 9, 9. Now let us now look out for the union. So the union of A and B, the set which is 4, we have 3, 5, 8, 1, 7, 9. So these are the elements which are in the union A and B. So elements which are not in the union of A and B should lie outside, but they remain within the universal. So if the whole of this is the universal, now we are going ahead to look out for elements which are going to be outside the union. Elements which are not part of this, but they are within here, the universal. So let's first of all identify the universal for here. So the universal has a 2, it has a 4, it has a 3, it has a 5, it has 8, it has 1, it has 7, it has 9. So the elements which remain, they are outside the universal of A and B. So they come in this space here. So I have a 6, I have a 10. They are outside the universal. So Roman number 1, they need us to find A intersection B. A intersection B is a set which has 3, 5, 8. Roman number 2, A union B. Members, you can see that we have already got A union B is here, 4, just transferring 3, 5, 8, 1, 7. Roman number 3, we need A intersection B complement. It means remove B. A intersection B complement. To complement means do away with intersection B complement. We shade the whole set B. We are going to remain with elements 2, number 4, A complement intersection B. This means that we have to do away with the whole A. So if we do away with the whole A, we're going to remain with the elements 1, 7. Please, we are looking at A and B. Don't jump outside here. We are looking at A and B. Next, we need 5. A complement intersection B complement. We don't want A and we don't want B. In other words, we don't want the union of A and B. So we don't want A means we are going to share the A. We don't want B, we share the B. So what remains, but still existing within the universal, is what we need. So what has remained, we have those two elements, 6 and 10. So someone can say that the universal is equal to, is comprising of two regions, A union B plus A union B complements. This is the conclusion. So when you get elements of the universal plus the elements which are outside here, give us the whole. Have example 2. Given that set P, which is a set of all factors of 90, and Q is a set of all factors of 60. We need to find, number 1, number of elements in P intersecting Q. Number 2, number of elements in P union Q. Number 3, number of elements in P complement intersection Q. Now, before we handle this question, we have to find set P and set Q. Set P being factors of 90. So we look out for factors of 90. So we need to first of all find the factors of 90, and the set P becomes a set with the elements. P is the set with the elements 1. Because we are looking out for factors of 90, of 35. Set Q is a set which has factors of 7. They are 1, 3, 4, 5, 10, 12, 15, 36. Next, we need to find the elements which belong. We need to find a set of elements which belong to P. Find P intersection Q. We need the set of shared elements. 1 is shared, 2 is shared, 3 is shared, and 5 is a shared element also. 6 is a shared element, and 10 is a shared element. 10 is a shared element. 30 is a shared element. We stop there. So this set is a set which has elements 1, 2, 3. So on this one will be stars. As a result, the number of elements in the P intersection Q, we're just going to count these elements here. 1, 2, 3, 4, 5, 6, 7, 8. So there we have 8 elements. Next, we need to find the union of P and D. So the set which is the union, I'm going to write these ones with the stars first. Those ones which are belong to the intersection. Remember, there is no element which has to be there. Then I go to set P and I look out for those without stars. I have 45. We go and do the same for the set Q, those without stars, but there are 12. There is 34. 4 is 12. So the elements which are in the universal are all of these. And now, ultimately, we can be able to find the number of elements in P union Q. So we count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Roman number 3, we need to find the elements which are not in the Q, in the P. Elements which are not in the P, that's what it means, P complement intersection Q. Elements which are not in the P, but they are found. So we go to set Q here. We look out for those elements which are not shared, and those elements do not have stars. So what are those elements? We have 4, we have 12. So the number of elements in the P complement intersection Q equal to 3. So we are done answering this question of ours. Next, I need to give you a trial question to practice the knowledge which you have or achieved here today. So the number which you are going to try is here. Try this one. Given the set P, which is a set of all triangular numbers less than 30, and the Q is a set of all factors of 60. So we need to find number of elements which belong to P intersection Q. Number of elements which belong to P union Q. Number of elements which belong to P intersection Q complement. 4. Number of elements which belong to P complement intersection Q. So that's the number which you are going to try out during your free time, please note it down. We are still proceeding with this lesson. I have another type of numbers which we may have to stay with me. So we got another number here. If the universal is a set which has elements x such that x ranges between 0 and 13. A is a set such that x ranges between 1. B is a set of x such that x ranges between 4 and 11, where x is an integer and that symbol is the universal set. They need us to find the number of elements in A intersection B. Number of elements in A union B. Number of elements in A intersection B complement. And number 4, number of elements in A union B complement. We shall start from 1, 2, and so on up to 12. So set A equal to, shall start from 2, 3, 4, and so on up to 9. We have set B is having values which range between 4 and 11. 11 not start from 5, 7 up to 10. Now after identifying our 3 sets, we now have to go ahead and concentrate on A and B by looking out for the shared elements and be putting stars on them. That's the step. So shared elements, I have 5, 6, I have 7, I have 8, I got 9. Those are shared elements. So I can proudly write that A intersection B is a set which has elements 5, 7, 6, 7, 8. For that reason, we have N A intersection B. The number of elements in A intersection B are these ones. We count 3, 4, 5. We're moving to the next one, A union B. A union B, we have to concentrate on the union of the two. So let's write A union. The first thing you write are the shared elements, and those are shared elements. Next, we go and write those elements which are in A but not in B. We have 3, 4. Then elements which are in B are not. So this is our union of A. Therefore, the number of elements in A union B is going to be equal to, count this, 3, 4, 5, 6, 7, 8, 9. So we have 9 elements in the union. That's done. Going to the next. A intersection B complement. We need to find the A intersection B, which I'm interested in. So we have to 3, 4. Consequently, number of elements in the A intersection B complement 3. We now proceed to the last one, A union B complement. We want elements which are outside the union, but they are within the universal set. Elements outside the union of A and B, but they are within the universal set. What does that mean? We are going to exclude the union within the universal set, and whatever remains a set of our interest, A union B complement. So let's first exclude by putting stars. I have 5. The universal 5, 6, 7, 8, 9, I have 2, I have 3, I have 4, I have 10. So whatever remains is outside the union of A and B, and that's what we want. So we have 1, elements 1, we have 11, 12. So the number of elements in A union B complement are 3. We shall also try if the universal is a set of X such that X ranges between 1 and 4. Set A is the set of X such that X ranges between 2 and 9, and 9 being inclusive, and set B being a set of X such that X ranges between 6 and 11 inclusive, where X is an integer, and that symbol is the universal. Number 1, number of elements in A intersection B. Number 2, number of elements in A union B. Number 3, number of elements in A intersection B complete. Number 4, number of elements in A union B complete. So that has been our examples for the two-set problem, but we shall have to continue with the algebraic two-set problem. In the next video, we shall look at a two-set problem with the algebra. Don't forget to subscribe and hit the notification bell to be receiving more videos about every topic has to be dealt with. So after two-set problem, we shall move to a three-set problem. Stay with me. And please tell a friend that this nice channel has come your way, and this will make you get a distinction in your math. Thank you very much.